All right, this is going to be the video for the review for assessment number 7. And all the questions in number 1 are based off of this graph down below, so I'm just going to be looking at that. So the first question, the zeros. Remember, zeros also means x-intercepts. So I'm just going to go and mark those. So here are my x-intercepts, here, here, and here. And then since they were from Desmos, the graph, I have them labeled right there. So you could put the whole coordinate, or you could just put the numbers like -4, what's the next one, 1 and 5. All right, so factors. So the factors of these things, that would have been x plus 4, x minus 1. Remember, they were the things before you got them to be zeros, and then x minus 5. All right, which of the zeros is a double root? So a double root is when your graph comes down and kind of bounces. So it bounces right there, it comes back up. So that indicates that that -4 was a double root. All right, intervals of increase. So increasing and decreasing, they have to do with kind of like the maxes and the mins. And so I'm going to mark this graph up. Right here, before this, from -infinity to that number, -4, this graph is decreasing. So this section I'm going to name decreasing. Then the next section, this little piece right here, it's rising. So from -4 to that coordinate right there is -1 for my x value. So I'm going to say -1. That section is increasing. Okay. Then from -1 all the way to right here, this whole section there is decreasing. So that's 3.5, the x value. So this section, decreasing. All right, and then the last section from 3.5 on to infinity, that part is increasing, positive slope. So those are my little sets of intervals, or my parentheses that I'm going to say. So increasing parts, from -4 to -1, so -4 to -1. Then the next increasing part was over here. That was 3.5 to infinity. 3.5 to infinity. So remember, these are intervals. They're not points anymore. So the decreasing areas were -infinity to -4. And then the other decreasing part was from -1 to 3.5. All right, number of turns. So I see 1, 2, 3 turns in this graph, which means it might have been a 4th power, x to the 4th. The y-intercept is right here at 0 and 1.6, and a local maximum. So I would probably maybe name this local maximum -1 and 2.16. Right, and then a local minimum. So you could pick either of these 2 points for a local minimum. I'm going to put -4, 0, because actually, you know, this other point here is, 3.5, -4.219 is also a local minimum, but more importantly, it's the absolute minimum. So I'm just going to use the other one. And it said only name one. So end behavior. Well, both ends of this graph is going down. The right side over here is going up, is going up to infinity, and the left side over here is going up to infinity. So both of those things are positive infinity. All right, number 2. So number 2, we're going back to some old problems here. This is composition of functions. So remember, when something says f of g of x, like letter A does, we're going to take g and plug it into f. F is the boss. So I have -3. I'm going to put something there, plus 4. So what I'm going to put in that empty space is I'm going to put 2x minus 5. I'm just going to work it out. So -3 times 2x is -6x. -3 times -5 is plus 15. And I have this plus 4. Whoops. So when I'm done, I'm just going to simplify. My answer would be -6x plus 19. All right, then for letter B, g of f of -2. So this one I'm going to work my way out. I know how to figure out f of -2. So f of -2 is when I take -3, put a -2 for x, plus 4. I'm plugging -2 into this problem. So I get 6 plus 4, which is 10. Well, I'm going to take that answer now, and I'm going to plug it into g. So put a 10 into the other problem. So 2 times 10 minus 5. I'm plugging in a 10 right here. All right, so 20 minus 5 is 15, and that is the final answer. All right, number 3. 3 is asking me to factor this expression. So when I factor this, I look at this, it's all in order, like highest degree to lowest degree, and it has 4 parts. So I'm going to do a splitting. This is factoring by grouping. So these two pieces have 5 and x squared in common, which leaves me with 3x minus 2 when I divide that 5x squared out, when I factor it out. Minus 18 and 12, best thing is a 6 in common, which leaves me with 3x minus 2 again. Right? So if you want to, you can kind of like say, oh, I'm dividing by -6, divide by -6, and then you can see how you're getting those answers. Or here, divide by 5x squared, divide by 5x squared, if that helps you. All right, so when I look at this thing in blue, I have 3x minus 2 in common. Oops. Just going to pull that out, and then I'm going to write what's left, 5x squared minus 6. Now in class, we kept going because we were looking for solutions. We solved this, but on your test, you're not going to have to do that yet. So this is it. It's factored. That's all I want to know. All right, number 4. List the 4 transformations from y equals x squared. All right, so here's the first one. That negative sign right there is causing a reflection. Let me spell reflection correctly. All right, this 1/3, that's causing a shrink. Everything is 1/3 of its height that it used to be. This x plus 4 inside here is causing you to move left 4, and the -5 is causing you to move down 5. All right, over here, number 5, good old quadratic formula. So I got to fix this up, minus 2x squared, minus 2x squared here. So I get 3x squared minus 4x plus 6 equals 0. All right, so I got my quadratic formula. A is 3, B is -4, and C is 6. So I say x equals, and there it is up there, negative b. So a negative of a -4 is positive 4, plus or minus the square root. So this b squared, a lot of people mess up this b squared. Well, when you square a negative, because b is -4, you always get a positive. So don't type it in your calculator, just do it. You know, -4 times -4 is 16. Minus 4 times a is 3, and c is 6. Over 2 times a, so 2 times 3 is 6. All right, let's see, 4 plus or minus, I need that radical. All right, so I'm going to go grab my calculator and figure out my discriminant. All right, so I need 16 minus 4 times 3 times 6. All right, so negative 56. And just to help myself out, 56 divided by 2, what is that? 28. All right. So there's a negative 56 in here. Whoops. Negative 56. So if I take 56 over here, 2 times 28. 28 is 4 times 7, and then I got 2 times 2. So I got a 2 to come out, and a 14 staying in. So when I reduce this, I get 4 plus or minus. 2 comes out with my I for the negative, and then I have square root of 14 all over 6. So my final answer, these 4, 2, and 6 all reduced by 2, so I'll say 2 plus or minus I radical 14 over 3. That would be my final answer, 2 answers. All right, this one here is asking me to solve by factoring. So I'm going to first notice that these all divide by 2x. So I'm going to pull out a 2x, a GCF. So that leaves me 2x squared plus 11x plus 14. All right, so leave the 2x out there. He's going to be part of my answer. And so then I'm going to get 2x and x to make this guy right here. 14, let me try 7 and 2. So I can't put the 2 with the other 2, so I'll put 2 back here and 7 there. So let's check. 4x, 7x, yep, that's 11. Everything's positive. So remember, I'm supposed to get 3 answers from this problem because it's x to the 3rd. So this answer, when does 2x equal 0? We'll solve that, you get x equals 0. This one, when does 2x plus 7 equal 0? You solve that, take away 7, divide by 2, you get negative 7 over 2. This one, when does x plus 2 equal 0? Well, subtract 2, you get negative 2. So there's your 3 solutions. So your solutions are 0, negative 7 over 2, and negative 2. Also, you can see those on the graph. All right, end behavior. So end behavior, I hope you know from class, depends on the highest degree. So the highest degree portion of my equation here is this piece right here. So if you want to, you can do this on the graph. You can make a graph of this if you've forgotten the rules. But you know, if you have an odd degree, then the ends of your graph go opposite ways. And so normally you would say that they go, right side goes up and left side goes down. But this has a negative 3 in front of it. So it's going to switch left side up, right side down. So if you forget that, you can always graph the whole problem or just graph the front, graph the highest power. So graph -3 x to the 5th, and there you go. Left side goes up, right side goes down. So this part, this piece, this question right here is talking about the right side when x is infinity. That is this piece right here, so I'd say negative. This is talking about the left side, so that's this piece right here, so I'd say positive infinity. All right, number 8, factor. We got good old cubes here. So little part, big part, trinomial. X times x times x makes x to the 3rd, so there's an x. 5 makes 25, so 125, so 5. Do square and multiply square. So square the x squared. Multiply x and 5 together, 5x. Square the 5, so 25. Then you say SOAP. SOAP is your signs. So you come through, you have the same sign, opposite sign, always positive. All right, number 9 is a throwback to last test. So to do this, these are my statistics. I'm going to grab my calculator and enter this in my data. So stat, edit. I already got some numbers in there, so I'm going to go up, clear and enter, clear and enter. All right, so I got 1, 2, 3, 4, 5. All right, and over here, 93, 140. Ugh. All right, so once you get your stuff in there, it says write the quadratic equation of best fit. So I'm going to press stat again, go to calculate, and go down to number 5. Only thing I have to do is type into store, do alpha trace to grab y1. So it puts the answer in y1, and then calculate. All right, so I'm going to copy that so I can have it on my screen so it won't go away. Ugh, hang on. That's what I wanted. All right, so let me see. I got -14.2. So y equals -14.2 x squared plus 93.6, let's say, x, and then plus 13. All right. So this question says, what's the approximate height at 6.5 seconds? So I'm going to get my calculator and plug in 6.5. So I'm going to do alpha trace and grab y1, plug in 6.5. And at 6.5, it would be 20.8, let's say. We want to say 20.8 feet. That would be the height of the ball at that time, so on and so on. Okay, last question. So list the x and the y-intercepts of this polynomial. So there's a couple ways you could do this. If you want the x-intercepts are when the equation equals 0. Okay, so if you wanted to, you could split this problem, factor it, take out x squared and get x plus 5, minus, take out 9 and get x plus 5. So you get x plus 5 and x squared minus 9. So that factors even more to x plus 5 and x plus 3 and x minus 3. So if you understand that and you want to do it, there's your x-intercepts, -5, 0, -3, 0, and +3, 0. And your y-intercept is sitting right here, because your y-intercept is when x equals 0. So if you put 0 for all these x's, the only thing that's left is -45. All right, now alternately, if you do not want to do it the algebra way, you could graph this. So if you graph this problem, all right, so you graph this thing, you got, let's see, x to the 3rd plus 5x squared. All right, you just have to be careful and look at the picture. I see it crossing at -5 and -3 and +3. I don't see the y-intercept, but should you go to the table, there's your answers. -5, 0, -3, 0. Here's your y-intercept, 0, -45, and then 3, 0 right there. So you have them all on the table. Okay. All right, that is it. I'll see you in class. Bye-bye.